Guys, this is the third time I'm recording these notes because the first two times were epic fails. So, I'm sorry if I talk really fast because this is the third time I've talked through these notes. Okay, today we're looking at special right triangles. Special right triangles are our 45, 45, 90 and our 30, 60, 90. They're called that because of the angles that are inside of them. If we take a look at this, the special property of 45, 45, 90 is that the legs are congruent to each other. We know those are the legs because they come out of the 90-degree angle. The other special property is that we can actually go from a leg to the hypotenuse if we multiply by radical 2. And then vice versa, we can come down from the hypotenuse to a leg if we divide by radical 2. 30, 60, 90s are a little bit different in the fact that the legs are not congruent. Okay. One of the important things to note is that everything has to go through the short leg. How do we know which one is the short leg? Opposite of 30 degrees is always the short leg. So if it's hard to tell by the picture, just find the 30-degree angle and go opposite. So 30 degrees, opposite. That means everything is going to go through N. Okay? So to go from the short side to the long side, you multiply by 2. And then to go backwards, right, you would divide by 2. Then to go from the short side to the long side, you multiply by radical 3. And then to go backwards, you divide by radical 3. Knowing those properties, that's how we're going to answer these questions below. Notice it says answers should be exact. Okay? Exact means they have to have radicals in them. It also means no decimals are accepted. Okay, that's exact answers. So taking a look at this, we have one of the legs, 6, because it's coming out of the 90 degrees. The other leg coming out of the 90 degrees is this x, so that means x is equal to 6. To go from a leg to the hypotenuse, you multiply by radical 2. So that tells us y is 6 radical 2. All right, number 2. This time we're given a leg, and the only thing we need to find is the hypotenuse. So 9 radical 2, you multiply it by radical 2 to find the hypotenuse. That's going to give us 9 radical 4. Well, radical 4 is really 2, so that's just 9 times 2, which tells us 18 is equal to x. Number 3, still another 45, 45, 90, but this time we have to go down. So we're going to divide by radical 2. So 5 divided by radical 2. Remember, radicals cannot be in the denominator, so we have to rationalize the denominator by multiplying by radical 2 over radical 2. Gives us 5 radical 2 over radical 4, which radical 4 is just 2. So 5 radical 2 over 2, and that's x and y because the legs are equal to each other. Number 4 is our first 30, 60, 90. Okay, 30 degrees is up here and the one that we don't know, so that makes the short side 11. So then to go from the short to the hypotenuse, you multiply by 2. So 11 times 2 means x is 22. And then to go from short side to long side, you multiply by radical 3, so that tells us y is 11 radical 3. All right, let's take a look at number 5 here. Number 5, we have the short side again, so we can go short to long, multiply by 2, so 5 radical 3 multiplied by 2. Remember, only the numbers outside of the radical get multiplied, so that would give us 10 radical 3 would be x. Be careful not to multiply 2 by 3, that's a mistake. Going the other way, we have 5 radical 3, we have to multiply by radical 3, which gives us 5 radical 9, which 9 is 3, so that's 5 times 3, which gives us 15 for y. And last on this page, we have number 6. Number 6, remember we have to go through the short leg. Short leg is opposite of 30 degrees, so we have to go here first. So we divide by 2. 16 divided by 2 gives us 8 for y. And then to go from short to long leg, we multiply by radical 3. So 8 radical 3 is x. All right. And that's the first page. So, on to the second page. The second page, really, guys, is just a table that we need to fill out. This table is super important. You're about to see the numbers that we get from this table in the rest of Unit 8. So, like, for the rest of this month, basically. And it would be very helpful to memorize this table right now, because it just makes all of the homework way easier. It makes all of the upcoming things a lot easier, especially when we get into this thing called the unit circle. So, gosh, I cannot draw a star. All right. 30 degrees. It says, use the model triangles above to fill in the table below. So the sine of 30 degrees. So we go 30 degrees. We go sine is opposite over hypotenuse. So that would be n. What the heck? That would be n over 2n. So the n's cancel. We get 1/2. Cosine would be n radical 3 over 2n, because 2n is the hypotenuse. Cancel the n's again, and we get radical 3 over 2. And then the tangent of 30 degrees is n over n radical 3. N's cancel, and we get 1 over radical 3. But we have to rationalize that, so we get multiplied by radical 3 over radical 3, which gives us radical 3 over 3 for the tangent. Remember, cosecant is 1 over sine, so then we just take what we got for sine, which was 1/2, and we put 1 on top of it. So 1 over 1/2 gives us 1 times 2 over 1, which gives us 2. 1 over cosine is going to be 1 over radical 3 over 2, which that's going to become 2 over radical 3, multiplied by radical 3 over radical 3, gives us 2 radical 3 over 3. And then the last one, 1 over tangent. The tangent that I would use, guys, is the original one, unrationalized. So if we put 1 over radical 3, that would just give us radical 3 for the cotangent, which is a lot easier than taking radical 3 over 3, flipping it, and making it 3 over radical 3, and then simplifying. Instead, if we just use 1 over radical 3 and we flip it, it becomes radical 3. All right, taking a look at this, guys. If you look, 30 degrees and 60 degrees are in the same triangle. So guess what? The numbers that we get for 30 are going to be very similar to the numbers that we get for 60. So if we look at the sine of 60 degrees, this time we go opposite, which is n radical 3, over the hypotenuse, which is 2n. Cancel those out, and we get radical 3 over 2. So check that out, right? Cosine of 30 degrees is actually equal to the sine of 60 degrees. So there's a bunch of these properties that are going to start showing up. Cosine of 30 is equal to the sine of 60 degrees. All right, let's take a look at the next one. So cosine, this time we go adjacent. So adjacent is n over the hypotenuse, which is 2n, gives us 1/2. So check that out. The sine of 30 degrees is actually equal to the cosine of 60 degrees. These properties down here, you don't need to memorize, but they're just properties that will help you memorize these numbers. Taking a look at tangent next, right? Tangent is going to be opposite, which is n radical 3, over adjacent, which is n. So that just gives us radical 3. Which, where did that come from, right? Looks like the tangent of 60 degrees is equal to the cotangent of 30 degrees. Cosecant is 1 over sine, right? So we're going to go 1 over radical 3 over 2, which becomes 2 over radical 3, which we've already done that simplification. It's 2 radical 3 over 3. Okay, so another property comes up, right? Secant of 30 degrees is equal to the cosecant of 60 degrees. But that makes sense, right? Look at this. Because the cosine of 30 degrees is equal to the sine of 30 degrees. So then the secant of 30 degrees should be equal to the cosecant of 60 degrees. All right. Next one is the secant, right? So that's 1 over 1/2, which gives us 2. And then lastly, the cotangent, which is 1 over radical 3, which is going to give us radical 3 over 3 when we simplify, right? That simplification comes from the original tangent of 30 degrees. All right, let's fill out this last row. 45 degrees is kind of on its own. The numbers are going to be different, and that's because they come from a different triangle completely. So if we take a look at 45 degrees, if we want to do sine, we have opposite n over hypotenuse, which is n radical 2. Notice that I use the bottom right, but if you use the top left, opposite over hypotenuse would still be n divided by n radical 2. So it doesn't matter for 45 degrees. You can use either 45-degree angle. So that's 1 over radical 2. We simplify this, and we get radical 2 over 2. Guess what, right? When we go cosine, we go adjacent over hypotenuse. That gives us n over n radical 2 again. It's going to be the same exact thing that comes out, radical 2 over 2. And that's because the legs are the same. So the sine of 45 degrees is actually equal to the cosine of 45 degrees. Tangent is a pretty neat one, because if we go tangent, we go opposite over adjacent, so that's n divided by n, which just gives us 1. And then from here on out, it's going to kind of be a matching game, right? Cotangent is just 1 over 1, which gives us 1. Sine, or cosecant, sorry, is 1 over the sine. I'm going to use 1 over radical 2, because that's way easier than trying to simplify 1 divided by radical 2 over 2. If we do that simplification, it would just give us radical 2. And then guess what? Because they're both the same thing, sine and cosine, the cosecant and secant are also the same thing, radical 2. All right. So this table, super helpful to memorize these numbers. Like I would say, okay, the sine of 30 degrees is equal to 1/2. Awesome. The tangent of 45 degrees is equal to 1. The cosecant of 30 degrees is equal to 2. Okay? Knowing these kind of things is going to be so helpful for later in this unit. So if you want to start trying to memorize those things now, by all means start doing that. If you don't and you want to just keep practicing with more and more numbers, that's also a great thing to do. As always, guys, if you have any questions, please ask me during Zoom, which is 11 to 2. If you can't get on then, just always drop a discussion question, and I'll make sure I get to those by the end of the day sometime. All right. I hope you guys all have an awesome day, and hopefully I'll talk to you soon.